Yeah, I will get right into it. I know people are sacrificing their lunches likely, so we will get started. I'd just like to welcome everyone for attending our first Green Bagger of this semester, and I'd like to thank Jacey in particular for presenting. I know we are all excited to hear your work. But before I get too much into Jacey's presentation today, I'd like to give a little introduction to who I am and kind of how I heard about the Canadian Society of Agronomy, for those who don't really know or maybe are not members currently. So I'm Alexa Peterson. I'm currently the acting student rep on the Canadian Society of Agronomy. I joined the CSA last year, and I had heard about it through my own professor, who was a member, but also he suggested it was a great way to meet people and possibly present my work at the annual meeting. So I got into it. I was able to listen to Green Baggers from other students, and it really gave me a sense of community, especially after COVID, of connecting with graduate students across Canada and hearing about work being done in all aspects of agriculture. And I would definitely encourage, if you aren't a member, to join. It's great for networking opportunities as well. Specifically for graduate students, at our annual meeting, we have events for graduate students in particular. We also have awards, and it's a great way to get access to our career opportunities on our job board, which is really filtered towards people with a plant science, crop science background. So more specific than looking on Indeed as well. And great access to our newsletters and our scientific journals. You can be part of committees as well. So specifically, students membership sign up is currently active. You can get our CSA membership for $30, or you can bundle with Canadian Society of Horticultural Science and Society of Soil Science as well for $40, which is a great deal. So thank you for listening to that little spiel. I'll get into the main event today, which is Jacey's presentation. So a little bit about Jacey. She grew up in northern Alberta, and she was surrounded by agriculture. But she wasn't quite sure how that interest would fit into her life. She graduated high school in 2017 and was hired by a research farm. And she fell in love with agricultural research. Throughout her degree, she returned to that farm each summer. And in 2021, Jacey graduated with a Bachelor of Science in Agriculture and a major in Sustainable Agricultural Systems from the University of Alberta. The same year, Jacey started her Master's of Science, focusing on the best management practices. In 2022, Jacey transferred to a PhD program at the University of Alberta, where she is currently studying the wheat production systems on the Canadian Prairies, and she will give us a little summary of her research that she's been conducting over the past 2 years on trials affecting the use of varietal mixtures of Canadian Western red wheat and Canada Prairie Spring Red wheat in both conventional and organic systems. So with that, thank you again, Jacey. I will pass it over to you.
Thanks, Alexa. So I'm Jacey Toerper, PhD student under the supervision of Drs. Gorham, Barras, and Spanner. And today I will be talking about the use of cultivar mixtures for enhanced yield and yield stability in spring wheat. So just a little rationale behind this research. So spring wheat is a really significant crop that's grown across the Canadian prairies. Nationally, we have about 27 million acres of wheat. And there are two main classes of wheat that are grown: Canadian Western Red Spring Wheat, or CWRS, and Canada Prairie Spring Red Wheat. They're both known for their high yields and high protein content. We also know that climate change is creating these variable weather patterns, which may affect wheat production. So if we have these variable climate patterns, we have variable precipitation and extreme temperatures, that could definitely impact wheat production. It's something that we don't necessarily want, especially if it's negative. And so we have to come up with a way to protect these yields, to protect the stability of this crop. So we know that increasing biodiversity can improve yield and yield stability in the natural world, but also in agriculture. So there have been many studies done in the natural world, say in native grasslands, looking at the interspecific diversity and how that affects production. Also with intercrops in agriculture, and then in cultivar or varietal mixtures, there have been many studies done as well, and only a few done on the Canadian prairies. So for this study, we looked at both CPSR wheat and CWRS wheat, as these are the main two wheat classes grown here in the prairies. And for each class, we looked at 5 different cultivars. And I should mention the wheat classes that we looked at were kept separate. They didn't interact with each other, but we did the same experiment on both. So we had 5 cultivars, and we grew them in pure sand and then all possible 2-way and 3-way mixtures, which created 25 treatments per class. At each site, we had 3 repetitions, and they were grown in a complete randomized block design. And this study that I'm working on currently started in 2021 and is going until this growing season 2023. So I have data until 2022. But there was a previous study on CWRS wheat done in 2016 and 17, and that data was collected from the same cultivar. So I've been able to add that data to this research for the CWRS wheat. So I'm going to start with Canada Prairie Spring Red wheat, and I'm going to look at some of the yield data that we have here. So first off, we can see that the cultivar, or the mixture of cultivars, as well as the environment, both had very significant effects on the yield. There was also an interaction between the cultivar and the environment. So the environment did have a significant effect on the cultivar, but not to the same extent as the individual components. I went through and ordered the treatments, so from lowest yield up to highest yield here. And I'll start at the bottom. So we can see that our lowest yielding cultivar was AAC tenacious, and the next 3 treatments that were low yielding also included AAC tenacious. And then up at the top here, our highest yielding cultivar or mixtures were or contained forefront. And then I just want to point out here that here our 3rd lowest yielding treatment contained forefront and AAC tenacious. So perhaps there's something going on here where AAC tenacious is reducing the yield of some of these high yielding cultivars. But I'll have to look more closely into that and determine if the yield of AAC tenacious is just so low that it does reduce the overall, or perhaps there's some competition going on there. Okay. I also looked at yield stability of the treatment. So this might be a little small to see, but I have an AMI biplot here. So on the x-axis, I have yield in tons per hectare, and then this vertical line just across the floor represents the overall average yield of all treatments and environments. And then on the y-axis, we have factor 1 or PC1, which is representing stability. So values closest to this horizontal 0 line are most stable, and as you move up in a way or down in a way, you have less stability. So I looked through my PC1 values and identified the values closest to 0. And then I have them written out here. So these treatments were the most stable. And as you might notice, we have forefront and AAC tenacious as components of these stable mixtures. So we have the highest and lowest yielding cultivars performing relatively stable between the different environments. And then we do have Lethbridge in 2021 under conventional management, Edmonton in 2021 under organic management, and Beaver Lodge in 2022 under conventional management were found to be the most stable environments. I also wanted to take a look at how management affected yield of the CPSR wheat. And there was a significant difference. And we can see here that the production under organic management was significantly higher. And we can also see here, there's not a great difference between the protein content. So these results to me are really interesting. And I think there's opportunity for more research here. So looking at the protein data, we can see that the only factor that had a significant effect was the site or the environment. And looking at management, so organic versus conventional, there was definitely not a significant effect there. So we know that for CPSR wheat, based on this, on the data that I have, that management does not negatively affect the protein content of the wheat. So now I'm going to move into Canada Western Red Spring wheat. And you'll see some similarities between the data here. So again, the cultivar or mixture and the environment both had a significant effect on yield. And there was a significant effect, interaction effect between the cultivar and the environment, but again, not to the same extent as the individual components. So again, looking at our lowest yield, we see here we have Lillian as either the lowest yielding cultivar or a component of the lowest yielding mixtures. And at the top here, the high end, we have CDC titanium as the highest yielding cultivar and a component of the highest yielding mixtures. I should point out here that there's less of a difference in overall yield from the lowest to the highest, where in CPSR wheat, there was over a 1 ton per hectare difference. So again, looking at the stability here, this graph is laid out in the same way. I've identified the more stable treatments. They're all mixtures, and they all contain CDC titanium and Lillian. So again, our lowest and highest yielding cultivars are contributing to some stability in some way or another. And again, I had more data for CWRS because I had the 2016 and 17 data from the previous study. And so we had Kernan and Edmonton in 2017 and Beaver Lodge in 2021, all under conventional management, were identified as the most stable environments. And I find it interesting that 2021, that's the year we had the really high temperatures and it was quite dry that year. So moving on to the effects of management on the yield. So again, we have a significant effect, but this time we have a higher yield under conventional management, and we definitely have a difference in protein content. So looking at what affects the protein content, in this case, management does affect the protein content significantly. The site or the environment also affects the protein content significantly. So I'm just going to spend a little bit of time going through some of the challenges and opportunities that I've identified in the use of varietal mixtures. So under challenges, what mixture works best for a producer? So this is something that might be challenging for a producer to decide. What cultivars should they be using? How many cultivars should they be using in a mixture? And what are they trying to achieve? Do they have disease pressure? Do they have insect pressure? Are they working with different abiotic challenges or stresses? So how did they know what to use? And will it be regionally dependent? So I'm hoping with this research to identify mixtures that work best in each location to determine if it is regionally specific because there is that cultivar and environment interaction, or in general, is there a cultivar that works well regardless of where it's used? Another challenge would be how will the producer physically create the mixture? If they're not available commercially, the producer is going to be responsible for mixing the different varieties together. So how will they do that? That's just another step that they would have to take, which would definitely be a consideration. Will there be a challenge in harvesting? So some of these cultivars have very different heights. So will having really short cultivars mixed with really tall cultivars be a problem? Another challenge that there could be is difference in length to maturity. So some cultivars may mature several days before another component. So how will a producer manage that? And another consideration is if there will be a challenge in selling the grain because they are selling a mixture, not a pure crop, not one cultivar. I don't know how big of a challenge this will be. I do know that a lot of wheat that goes for the end use for food products ends up being mixed anyways because they're trying to achieve a certain protein concentration. So if the overall sample is mixed, it might be okay. So again, the opportunities with varietal mixtures is that we are able to increase stability under variable conditions depending on the mixture that's used. And it might add a layer of insurance. So we're creating an opportunity to develop mixtures in the field that can resist or tolerate known or even unknown abiotic and biotic stresses if we have cultivars with the different disease packages or different abilities to tolerate drought or other variable conditions. So there's definitely opportunity there. And I just wanted to thank all the partners and people that have made this project possible. Thank you.
Thank you so much, Jacey. That was a great presentation. I guess we will open it up for questions. So if you have a question for Jacey, please raise your hand. Thank you, Sherry.
Jacey, really nice presentation. Good job. So just a quick question, on that CWRS data where you were seeing the difference in the organic and the conventional, did you have organic and conventional sites at the same physical location, or was there possibly an additional environmental factor like different rainfall at organic sites versus conventional or something like that?
So they were not at the same physical location, but I did have conventional and organic both in Edmonton, but not at the same site. So I'm collecting the weather data now, so I'm definitely going to take a deeper look into if there was a significant difference in the weather, if that could have played a role for sure.
Or possibly soil type, even if they are.
Yes, definitely.
Thank you.
Thank you.
Perfect. Any more questions for Jacey? Yes, Hiroshi?
Can you hear me?
Yes.
Oh, okay. Right. I'm gonna video on. Sorry, I'm looking after my daughter right now, so it may be noisy, but anyway, thank you so much, Jacey. It's a great presentation. I enjoyed it. And I have maybe two quick questions. First one would be what criteria or how did you pick the specific varieties for CPSR and CWRS for these trials? That's my first question.
I was not a part of the selection process, but a lot of these cultivars were developed by Dean Spanner in his breeding program. So I think there's maybe a little bit of bias there. He wanted to test out some varieties that he had worked on. I know a lot of the cultivars are not high acreage cultivars grown in the region. Some of them are new, so Forefront is a newer variety. So I think interesting to see how that works. And another part was that all of these cultivars have different disease packages. So I think there was the hope that by combining cultivars that would be able to, I guess, tolerate or resist different diseases if they were present to compare the effect or the performance. So I think those were the main deciding factors for cultivar selection.
Okay, thank you so much. So I think I may need to expand a little bit of my past question. So did you see any maturity difference among the mixture, and that would be a kind of issue for producers?
Yeah, so there is definitely some difference in days to maturity. And I think that could definitely be a challenge. You might have one cultivar that's just about ready to harvest and another one that's still quite green. So that definitely adds a challenge for producers in managing that, whether they have to wait and hope they don't start to lose seed from the more mature variety, or if they decide to desiccate. So it's definitely something that would have to be considered. And I think if we could create mixtures that have more similar maturities, that would definitely make things a little easier for producers.
Right. So that could be a kind of one recommendation for producers, maybe. Okay,
Sure.
and sorry, I don't want to take much of time, but I have another question. That so in one slide you show a CPSR conventional and organic field yield, and the organic one seems to be higher yielding for mixture. And I'm just wondering seeding rate for that, because usually organic farmers, they have like a higher seeding rate in terms of like weed competitiveness and so on. So what the seeding rate, and do you see any like a effect on the result for to look at conventional and organic mixture?
So we used a standard seeding rate of 300 seeds per meter squared at all sites and all years. So I don't think it was a difference in the seeding rate. So yeah, I have heard from someone, and it's definitely something I want to look into, is that potentially CPSR wheat might be interacting with the soil microbiome a little differently than CWRS wheat. So potentially there's something else going on that might be benefiting the wheat under organic production for the CPSR wheat.
Okay, yeah, that's all. Thank you so much, Jacey.
Thank you.
Perfect. Jeremy?
Thanks, Jacey. Great presentation. I had a question regarding the differences in response between CPSR and CWRS. I find it interesting that the varying range of response with CPSR was much greater. But because we don't see the full list of variety mixes, I was curious whether the data maybe demonstrated if one class benefited more or less from variety mixing than another. Like was there a higher proportion of higher yielding mixes in CPSR than CWRS? Like, was it weighted differently?
I'm not quite sure. I'd have to look back at the data a little more closely to see if there was a difference between the classes. I guess next step for some of my data analysis, once I have the 2023 data, is to go through and look at if the mixture out yielded the midpoint average of the cultivar grown in a pure stand. So I definitely want to compare that. I'm not sure what the effect difference was between the two classes. So that's definitely something to look into. I guess for the most part, these experiments were kept separate, but yeah, that's definitely, it would be an interesting comparison to make. To see
Yeah,
if one class benefits more than the other under this practice.
it makes you wonder whether, with all the collective CPSR varieties that you have in there, whether their total maybe disease resistance is slightly lower than the cumulative disease resistance of all the CWRSs, and maybe that's why you're seeing, I don't know. Anyway, thank you.
Yes, thank you.
Perfect. Thank you, Jeremy. Sherry?
Hi, Jacey. Just one more thought that crossed my mind as a bit of a flag. Since this experiment was designed, Lillian is not a CWRS variety anymore. It is now a CNHR. So I think when you present the results and publish them, that's probably an important flag to make sure you raise that. And the other consideration is the 1,000 kernel weight, and how when you have a mixture, if you have different sized seeds, how that might settle out. And was that something you struggled with a smaller size seed not mixing well with a larger size seed?
So I did not do the 1,000 kernel weight on for the previous year. I will be doing it this year. Someone else in like the different sites was doing it in the past. So I'm hoping to help with the one in Beaverlodge. So that could definitely have an effect if they're not thoroughly mixed. And it would depend too, I suppose, on how they were being counted, if they were counted by hand, and if whoever was counting was selective about what size they picked, or if they were done in a seed counter where, you know, if a mixed sample was put in, hopefully it would randomly, the seeds would come out and be counted that way. So yeah, I suppose depending on the method, there could have been some bias there affecting the 1,000 kernel weight.
Thanks.
Perfect. I will conclude our question period just to keep us on time. Again, thank you, Jacey, so much. Extremely interesting topic. I'd love to hear your updates next year to see how the project is moving forward. And to anyone else joining us, I would like to thank you again for your participation. And I hope you can join us for our next Greenbagger series on November 15th. You will be getting an email shortly on that, and you can follow us on LinkedIn for those updates. So thank you, everyone.